Okay, so hello and welcome back. So in this video we have another example, and the problem is, after some food is introduced into a petri dish containing bacteria, the number of bacteria in the dish increases rapidly. So it's about increasing the number of bacteria in the petri dish. So the relationship between the elapsed time t in seconds, so t is in seconds. Let me do this in red so t is in seconds. Since the food was introduced and the total number of bacteria, n of t is the total number of bacteria, is multiplied by the following function. So n of t is equal to 1000 times 8 raised to the power t. Now we need to answer this question about this whole situation here. The number of bacteria is doubled every how many seconds? So in order to understand every how many seconds is the number of bacteria being doubled, so we have the relationship between the number of bacteria, and which is n of t, and t, and t here is in seconds here, and you have t as the index of this number 8, which is your common ratio. So that means there you have no problem. Basically, it's not like, for example, 8 raised to the power t divided by 5, or 5t, or t divided by 2, or anything like that. So now if this relationship was like this, if it was like n of t is equal to 1000 times 2 raised to the power t, what we could tell about this would be that, well, when we start basically doing this whole research, there is 1000 bacteria in the petri dish. 1000 bacteria, and the number is being doubled because it's being multiplied by 2 every 1 second, because when t is equal to 1, then 1 factor of 2 is being multiplied by 1000. When t is equal to 2, then you have 2 factors of 2 here being multiplied by 1000. So every second the population is being doubled and doubled and doubled. Of course, it's not being multiplied by 1000. Actually, about this relationship, it would be like this. So it would be t in seconds and n of t, and then here you would have 0 when t is equal to 0. Your n of t is equal to 1000. When t is equal to 1, it is 1000 times 2. When t is equal to 2, it is 1000 times 2 times 2, and 3, for example, 1000 times 2 times 2 times 2, and so on and so forth. So every time you are incrementing your input by 1, your output is again being multiplied by another factor of 2, so on and so forth. But the problem is that now, based on the relationship that I have here, based on this relationship, I know that basically based on this, I know for every second, well, based on this situation, based on this relationship, every second the the number of the whole population, the whole number of bacteria is being multiplied by another factor of 8 and 8 and 8. So it's getting 8 times larger, 8 times larger, and 8 times larger. So actually the number of bacteria here is every second the number of bacteria is getting 8 times larger. But we want to know, for basically what we want to know here, the number of bacteria is doubled every how many seconds. So in how many seconds, in every how many seconds is the number of bacteria being doubled? So it has to be a fraction of a second, because every second the number of bacteria is getting 8 times larger, 8 times larger, and 8 times larger. So it has to be in a fraction of a second that the number of bacteria is being doubled. Now, how we can solve this problem? We need to do a basically based on the relationship that we have here. Based on this relationship, we need to create some sort of relationship. We need to create some sort of relationship between n of t and t. We need to create some sort of relationship between n of t and t in which this ratio, in this common ratio, is equal to 2, not 8. Because I want to know in how many seconds is, or in what fraction of a second is the number of bacteria getting doubled. So my the relationship that I currently have is n of t is equal to 1000 times 8 raised to the power t. You know that 8 is equal to 2 cubed. So I could rewrite this as n of t is equal to 1000 times 2 cubed whole raised to the power t. 8, I have written it as 2 cubed. And again, I can rewrite this as n of t is equal to 1000 times 2, and I can multiply this 3 by t, and this becomes 3t. This is one of the properties of exponential functions. I don't know if I've ever talked about this in any of my courses, but it's simply like that. So if you have x or a raised to the power b whole raised to the power c, you could write this as a raised to the power b into c. You could do this. It is complete. It's always allowed. Oh, well, at least for integers, I'm sure, but I don't know for other types of numbers. We need to look it up. But even for decimals, that's allowed. I suppose it's a general rule. So you can do this. So you can 2 cubed raised to the power t. You can write it as 2 raised to the power 3t. And now you have a new relationship based on the relationship that you had before, and now your common ratio is 2. So now every 1/3 of a second, the number of bacteria is being multiplied by 2, and again, and after another 1/3 of a second, the number of bacteria is being multiplied by 2. So, and I'm saying 1/3 of a second because let's say for example let's say this is your t and this is your n of t. So if your t is equal to 1, then you have, if your t is equal to 1, your output is going to be, well, let's start with the 0. If your t is equal to 0, your output is 1000. If your t is equal to 1, then you have 1000 times 2 raised to the power 3. 1000 times 2 raised to the power 3. If your t is equal to 2, you have 1000 times 2 raised to the power 6, and so on and so forth. So now this is not what we are looking for. I want to know in what should my t be, what should my t be in order for this whole index to be 1, because it has to be, if I want to know in how many seconds this only one factor of 2 is being multiplied by 1000, because I want to know basically in how many seconds the number of bacteria is being doubled. Being doubled means that the function has to produce this kind of output. So this kind of output means that the index of the index of 2 is 1. So the index of 2 being 1 means that 3t is equal to 1. So t has to be equal to 1/3. So 1/3 of a second. And 1/3 of a second is approximately 0.33, I suppose. 0.33, and continuing forever. So the answer is 33 seconds. Basically 0.33 seconds. And that is the answer here. Okay, so thank you, and I'll see you in the next video.